unexpected pandemic effect. Reduced pollution temporarily worsened methane levels. A recent study reveals a surprising climate dynamic: the sharp decline in human industrial activity during the COVID-19 pandemic increased atmospheric methane levels, not decreased them. This wasn't due to higher emissions, but because reduced pollution weakened the atmosphere's natural ability to break down the potent greenhouse gas. The temporary surge highlights a critical, counterintuitive interaction between human emissions and natural atmospheric processes. The atmospheric cleanup disrupted the study, published in Science on February 5th, found that 83% of the unprecedented methane spike in 2020 was directly linked to lower emissions of nitrous oxides, byproducts of combustion engines. These oxides play a crucial role in forming hydroxyl OH radicals, often called the cleanup molecules of the atmosphere. OH radicals destroy methane, carbon monoxide, and other pollutants by oxidizing them. When human activity slowed, so did nitrous oxide emissions, leading to fewer OH radicals and allowing methane to accumulate. This effect is particularly significant because methane is roughly 30 times more effective at trapping heat than carbon dioxide, although it doesn't linger in the atmosphere as long. The unexpected behavior demonstrates that simply reducing some emissions doesn't automatically translate into cleaner air. Atmospheric chemistry is far more complex. Biological sources also contributed, while the disruption of human pollution was the primary driver of the spike. Researchers also identified a 20% contribution from increased natural methane emissions. Extremely wet conditions in tropical Africa, exacerbated by La Niña and the Indian Ocean dipole climate patterns, flooded wetlands and boosted methane production from decaying vegetation and livestock. The isotopic signature of the excess methane pointed to a surge in biological sources. The study utilized satellite data, ground measurements, and advanced modeling to isolate the relative impact of these two factors. It confirmed that fossil fuel emissions remained relatively stable during this period, while biological emissions increased significantly. What this means for climate change: the surge in methane levels stabilized in 2023 as both the pandemic subsided and weather patterns normalized. But the event serves as a stark reminder of the interconnectedness of climate systems. Methane's short-term potency makes it a critical factor in near-term warming. The study underscores that focusing solely on reducing CO2 emissions is insufficient. Managing methane and understanding its complex atmospheric interactions are equally vital. As Professor Ewan Nisbet of Royal Holloway University of London explains, methane has a period of 10 years, so it's turning over all the time and telling us there's something big going on. This is a climate feedback, and the big biological sources are turning on, so we've got to work twice as hard. The findings emphasize that the climate crisis is not a linear equation, and unexpected consequences can arise from even well-intentioned interventions.